I want you to picture a scenario for a second, just, right off the bat here. You pull out your phone and you download a brand new app.
Right.
Like it's something you have never used before. Maybe it's a completely new piece of software for managing your schedule or some new social platform.
Yeah, some new startup thing.
Exactly. So you open it up, and before you read a single word of text on the screen, I mean, before you even think about looking for a tutorial or a help menu, your thumb just moves.
It just knows where to go.
It intuitively knows exactly where to tap, where to swipe, where to scroll. You navigate through this entirely foreign digital space as if you were the one who coded the thing.
Right. Yeah.
And, we take this for granted every single day. But think about the actual mechanics of it. How does your brain instantly understand the architecture of a space it has literally never been in before?
It's a wild question when you really stop and think about it.
Right. Because the reality is you are being gently, sort of invisibly manipulated.
Yeah.
Your thumb, your eyes, your attention, and ultimately your decisions, they're all being guided by a set of psychological rules that were actually formulated over a century ago.
Yeah, it really changes your perspective entirely once you realize that the intuitive feeling of a good app isn't just magic, it's biology.
Exactly.
We walk around assuming we are making these conscious, deliberate choices about where to direct our attention on a screen or what button to click, but your visual cortex is operating on a completely different timeline.
It's way faster.
Oh, massively. It is making structural decisions and organizing the visual hierarchy milliseconds before your conscious mind even boots up to process the information.
And that invisible architecture, that's exactly what we are decoding today for you. We are going on a deep dive into the psychological framework known as Gestalt principles. And to do this, we're pulling together some really fascinating source material.
Yeah, we've got a great stack of research for this one.
We really do. We have cognitive psychology papers that dive into the actual biology of vision. We've got detailed eye-tracking studies.
Those are my favorite.
Oh, they are so cool, right?
Oh.
Measuring exactly what the human eye does when confronted with different layouts. Plus, we've got UI and UX case studies from major tech companies and hard data on how interface design directly dictates human purchase decisions.
Which is huge. And, the goal here isn't just to talk about, abstract design theory.
Right.
If we unpack this correctly, it should fundamentally alter how you, the listener, view the digital spaces and even the physical spaces you navigate daily. Because once you understand the cognitive shortcuts your brain is taking, you start seeing the underlying matrix of, every website, every mobile app, every dashboard you touch.
You can't unsee it. And, a lot of modern UX literature talks about this in terms of user retention, like how to keep someone on a page for a few more seconds.
The holy grail of tech.
Exactly. But the research shows something wild. 94% of first impressions of a digital product are entirely design-related.
94%, that's almost the whole thing.
Almost the whole thing. And those impressions are formed in roughly 50 milliseconds.
Wow.
Yeah, 50 milliseconds.
Wow.
That is literally faster than the blink of an eye.
Right. So in that tiny window, the user obviously hasn't read the marketing copy.
Not a single word.
They haven't looked at the pricing. They haven't evaluated the feature set. Their brain has just taken a raw snapshot of the layout and made this massive, sweeping judgment about whether the environment is safe, trustworthy, and orderly, or, chaotic and dangerous.
So to understand how the brain does that so incredibly fast, we have to look at where this framework comes from. And it actually traces back to Germany in 1912.
Right, a long time before smartphone.
Oh, way before. We're talking about psychologists Max Wertheimer, Kurt Koffka, and Wolfgang Kohler. And they weren't looking at screens at all. They were studying something called the phi phenomenon.
Yeah, the phi phenomenon, which is essentially the optical illusion of perceiving continuous motion in a rapid sequence of separate static images.
Like a flipbook, right?
Exactly like a flipbook. Wertheimer was famously inspired by watching the flashing lights at a railroad crossing. And later, he experimented with a toy called a tachistoscope, which is a very hard word to say.
Yeah, try saying that 3 times fast.
Right, but it essentially flashes images at very high speeds. And the core realization was this: when you look at consecutive frames of a film, your eye is technically seeing isolated, static pictures separated by tiny moments of darkness.
Just a bunch of still photos.
Right. But your brain doesn't process it that way. It completely ignores the static nature of the input and constructs fluid, continuous movement.
It just fills in the blanks. They realize the brain is an active participant in reality, not just a passive camera that's like recording light.
Yes. Active construction.
And so Gestalt is a German word that translates roughly to form or unified whole. And the foundational rule they deduce from all this is a phrase that gets thrown around a lot. The whole is other than the sum of its parts.
It is so worth lingering on the specific phrasing there because people often misquote it, right?
Oh yeah, all the time.
They say the whole is greater than the sum of its parts.
Right.
But Wertheimer specifically used the word other.
Other. Okay, why is that important?
Well, think about when you look at a bicycle. You aren't perceiving a pile of rubber, some metal tubes, a chain, and some gears, and then, doing the math in your head to add them up.
Right, you see a bike.
You instantly perceive a vehicle. The human mind translates those disparate visual elements into a unified, meaningful whole that has entirely different properties than the individual pieces. It's something other.
Okay, that makes perfect sense. And this brings in the law of pregnance, right? Which is often referred to as the law of simplicity.
Yes, exactly.
And the underlying premise here is that the human brain is a fiercely demanding, highly efficient organ that is constantly seeking a state of minimal energy utilization.
It is trying to save power at all costs.
Right. When it processes visual information, it automatically forces complex, chaotic stimuli into the simplest, most orderly forms possible. And the sources gave this great way to visualize this. Think about soap bubbles.
Oh, the soap bubble analogy is great.
It's so good. When you blow a soap bubble through a wand, right as it comes out, it might emerge in this wobbly, chaotic, unpredictable shape.
Sort of oblong and weird.
Yeah. But within a fraction of a second, it naturally snaps into a perfect sphere. And it doesn't do that because a sphere is pretty. It does that because a sphere is the state of minimum surface tension.
Right. Physics.
Exactly. It requires the least amount of energy to maintain. The brain is basically applying that exact same thermodynamic principle to visual data.
Well, we have to consider the sheer volume of data the brain is dealing with here. The human visual system processes roughly 11 million bits of visual information every single second.
Wait, 11 million per second?
Every single second.
That is absurd.
It's a massive data pipeline. That data is hitting the retina, trialing down the optic nerve, and flooding the occipital lobe at the back of the brain. If the brain attempted to consciously analyze every single pixel, every gradient of light, every shadow, and every edge in your environment individually, cognitive overload would be instantaneous.
Your brain would just crash, like a frozen computer.
We would be completely paralyzed. So Gestalt principles are biological compression algorithms.
Oh, I love that phrasing.
Yeah, they are cognitive chunking mechanisms. They take millions of individual data points and compress them into a few manageable units so the conscious mind can actually function.
It makes me think of stargazing, actually.
Yeah.
You look up at the night sky, and objectively, you are looking at billions of burning balls of gas scattered totally randomly across the void of space.
Just total visual noise.
Right, but humans don't process random noise well.
Yeah.
So we look up, and our brains instantly connect the dots.
We make constellations.
We see a hunter with a bow or a giant bear or, a dipper. We chunk the stars together into constellations. Yeah. But looking at some of the design literature in our sources, there's this tendency to describe the brain as lazy because it heavily relies on these shortcuts to avoid doing the hard work of deep analysis.
Yeah, you see that word a lot in UX blogs.
But calling it lazy feels like a massive misunderstanding of the stakes here. I mean, if you are an early hominid walking through the jungle, you need to instantly separate the pattern of a leopard from the pattern of the dappled sunlight on the leaves.
Absolutely.
You don't have time to consciously analyze every leaf. This drive for visual simplicity doesn't seem lazy at all. It seems like a highly advanced, ruthlessly optimized survival mechanism.
Labeling the brain lazy is definitely just a modern UX designer shorthand for, minimizing user friction.
Yeah.
But in the realm of cognitive psychology and evolutionary biology, it is absolutely recognized as a hyper-optimized processing strategy.
Right.
Think about this. The brain consumes about 20% of the body's energy while only accounting for roughly 2% of its mass.
So it's a gas guzzler.
Exactly. It has an incredibly strict energy budget.
Oh.
If an environment, whether it's a literal jungle or a complex e-commerce dashboard, forces the brain to burn excessive calories just to figure out what it's looking at, the brain triggers a stress response.
It panics.
It wants to leave that environment immediately. That biological imperative to conserve energy is the entire foundation of user experience design.
Okay, so if we are biologically hardwired to scan our environments for specific patterns just to save energy and survive, we need to map out what those specific visual patterns actually are.
Let's do it.
So let's look at the core laws of perception, starting with how we organize static space, things that aren't moving. This involves proximity, similarity, and figure ground. Let's start with proximity,
Proximity is arguably the heavyweight champion of Gestalt rules.
the big one.
The absolute biggest. The principle states that elements placed close together in physical space are automatically perceived as a related group. And what makes proximity so critical to understand is its dominance. It overrides almost every other visual feature you can throw at a user.
Really?
Oh yeah. You can have objects of entirely different shapes, vastly different colors, and completely different textures, but if you put them physically close to each other, the brain insists they belong to the same family.
So space beats color and shape.
Space beats almost everything.
Let's put this in a real-world context for you listening. Think about walking into a massive convention center or like a high school cafeteria. You don't need to interview everyone in the room to understand the social dynamics.
You'd never have the time.
Right. You instantly know who belongs to which clique simply by looking at who is clustered together at which tables.
Yeah.
Even if the people at one table are wearing completely different clothes, different styles, different colors, the physical distance between them is the primary communicator of their relationship. Space dictates the relationship faster than the content of the objects themselves.
And that concept maps directly onto digital interfaces. Let's consider a digital form.
Like checking out of an online store.
Exactly. You're entering your shipping address. You have text labels like first name, last name, street address, and you have the blank input boxes next to them. The label first name has to sit almost flush against its corresponding input box, with a much larger gap of space below it before the next label begins.
So they look like a pair.
Right. Because of that proximity, your brain binds the label and the box together as a single functional unit. If a designer were to use mathematically equal spacing between all the labels and all the boxes down the entire page, the visual hierarchy collapses completely.
Oh, because it would just look like a giant list of unrelated items.
The brain wouldn't know which label belonged to which box, and frankly, no amount of color coding would easily fix that confusion. Proximity has to do the heavy lifting.
So if proximity is so dominant that it overrides the visual styling of the elements, it suggests that the empty space around the content is actually more important than the content itself. Like the negative space, the white space, is the actual architecture of the page.
The negative space is the structure, period. Without deliberate negative space, you just have a wall of noise. But obviously, the styling of the elements still plays a massive role, which leads us to the second principle, which is similarity.
Right, so if proximity is about grouping things by physical location, similarity is about grouping things by their visual identity.
Precisely. Elements that share visual traits, so color, size, shape, texture, or orientation, are grouped together by the mind, regardless of how far apart they are scattered across a screen.
We see this used to teach the brain functional grammar, right? Abstract systems rely on similarity to train the user without using a manual.
Yeah, you don't want to have to read a manual to use a website.
Exactly. When you look at a complex dashboard and you notice that, say, 3 disparate buttons on completely different sides of the screen all share the exact same shade of primary blue, and they all have the same rounded corners, your brain just logs a rule.
It creates a shortcut.
Right. It says, okay, these blue rounded things perform a specific type of primary action. Once that rule is established, the user doesn't have to consciously read the text on the next blue button they encounter. The visual identity signals the function.
It creates a tremendous amount of processing fluency. You just feel smart using it. And to anchor both proximity and similarity, the brain needs depth and focus. Which brings us to the third static rule, governed by the principle of figure ground.
Figure ground. This is the brain's automatic, immediate separation of a visual field into a focal subject, which is the figure, and the background, which is the ground.
Yep. The classic illustration of this in cognitive psychology is the Rubin vase.
Oh, I've seen this. It's the famous black and white image.
Right. Depending on how your brain locks in on it, you either see the black shapes on the outside as two faces looking at each other in profile, or you focus on the white space in the middle and see a single symmetrical vase.
But the wild part is you can't see both at the same time.
That's the key. The Rubin vase illusion is powerful because it demonstrates that figure ground perception is entirely mutually exclusive.
You can consciously force your brain to switch back and forth between seeing the faces and seeing the vase.
Right, flip-flopping them.
But you cannot process both realities at the exact same time. The visual cortex demands a clear, unambiguous hierarchy. It has to know what is the actionable object in the foreground, what is the passive environment in the background,
And we experience artificial manipulations of this constantly in digital spaces.
like pop-ups.
Exactly like pop-ups. When you are reading an article on a website and suddenly a modal window appears asking for your email address, the designer doesn't just slap the box over the text. The entire rest of the screen behind the pop-up usually dims to a dark gray or it completely blurs out.
Right, they're hijacking your figure ground perception.
They are brutally forcing the pop-up to become the only viable figure by neutralizing the contrast of the original page. The brain has no choice but to shift its focus to the new box.
Okay, so these three static principles, proximity, similarity, and figure ground, are the tools for organizing elements that are sitting still.
Right.
But modern digital environments are rarely static. I mean, they are characterized by scrolling, swiping, animations, and often deliberate gaps in information. The brain must have an entirely different set of rules for handling movement and paths.
Oh, it does. That opens up a much more complex problem. If organizing a static image relies on fixed space and contrast, what happens when the user starts moving through the environment?
The static rules immediately break down.
Completely. How does the brain cope with paths, motion, and missing pieces? This brings us to the principles of flow and imagination: continuity, closure, and common fate.
Let's break those down. Let's look at continuity first, or good continuation as it's sometimes called.
Right. The human eye has a strong biological preference for following the smoothest possible path, line, or curve.
It likes an easy ride.
Exactly. We heavily favor continuous flows over abrupt, jagged, or sharp changes in visual direction. When a series of elements aligns along a trajectory, the eye naturally jumps onto that track and rides it to the end.
And this biomechanical preference is exactly what dictates how we consume digital layouts, isn't it? Because eye tracking data consistently shows that users do not read a web page linearly the way they would read a physical novel.
Nobody reads a website like a book.
Right? We scan. And those scan paths are deeply predictable. We use the F pattern and the Z pattern.
The F pattern is everywhere.
So in an F pattern, the eye scans horizontally across the top navigation, right? Then it drops down slightly, scans horizontally again across the subheader, and then drops vertically down the left side of the page looking for bullet points. The eye is seeking continuous lines to ride.
Yes, it wants that smooth track.
If a layout forces the eye to constantly jump back and forth across the screen in a jagged, unpredictable manner just to find information, it creates severe mechanical fatigue in the eye muscle.
And that literal physical fatigue translates directly to cognitive frustration.
Which makes you close the tab.
Instantly. Then we have the principle of closure, which is arguably the most active and honestly fascinating mechanism from a neurological standpoint.
This one is so cool.
It is. Closure is the brain's innate tendency to actively complete incomplete shapes in order to perceive a whole recognizable object. If an image is missing outlines or has massive gaps, our minds refuse to accept it as just a collection of broken fragments.
We mentally draw in the missing geometry based on familiar patterns stored in our memory. Yes, the World Wildlife Fund logo is the absolute textbook example of this.
The panda.
The panda, right. When you actually analyze the WWF panda logo, there are no lines drawing the top of the panda's skull or its back.
It is literally just a collection of disconnected black ink blobs. You've got the ears, the eye patches, the arms, and the legs arranged carefully on a white background.
But nobody looks at that and thinks, what a strange collection of black shapes.
Because your occipital lobe actively hallucinates the white curves of the panda's head and back. Your brain reaches into its memory, retrieves the mental model of a bear, and does the heavy lifting to close the shape using the negative space.
The IBM logo operates the exact same way. It's just horizontal blue lines separated by empty space, but you see solid, distinct typography.
It's a testament to the fact that perception is a highly constructive process. You are constantly building the reality you are looking at.
You're not just a passive receiver.
Right. And completing that picture leads to the final dynamic principle, which is common fate. Common fate. This rule asserts that elements moving in the same direction at the same speed or moving in synchrony are immediately perceived as a single, unified entity, regardless of how diverse they might be individually.
We see this in nature all the time. Think about a massive flock of starlings in the sky or a school of fish. It might be 10,000 individual creatures, but because they pivot, bank, and turn in the air or water at the exact same moment, your brain stops tracking 10,000 individual entities.
It can't process 10,000 birds.
No, so it perceives one massive, fluid, undulating object. In UI design, the classic example is a drop-down menu or an accordion menu.
Oh, perfect example.
When you click a header and 5 distinct sub-options slide down the screen in a perfect unison, moving at the exact same pixel velocity, your brain binds them together. Synchronized motion creates absolute unity.
It groups them instantly.
Now, I want to circle back to closure for a second, because the active hallucination aspect is fascinating to me. It feels like listening to a song you know intimately, and right before the final resolving chord is struck, the audio completely cuts out.
Oh, man, I hate that.
But even in the silence, your brain plays that final chord in your head anyway. You finish the pattern.
You can literally hear it.
Right.
Yeah.
But that relies heavily on knowing the song. What happens when a designer relies on closure, providing incomplete visual information, but the user simply doesn't possess the prior knowledge or the cultural context or the memory to fill in the blank? Can this principle completely backfire?
Oh, it can fail catastrophically. Closure requires a shared mental model between the designer and the user.
Okay, give me an example.
If a designer creates an icon that is intensely abstract or minimal, say, they are trying to represent a save function using just 2 disconnected geometric lines, they might think it's very elegant and clean.
Because they know what it means.
Right, they built it. But if a user, perhaps someone older or from a different cultural background, doesn't have the mental framework to connect those 2 lines into a recognizable floppy disk or a cloud, the cognitive shortcut crashes. The brain tries to close the loop, searches its database for a reference, finds nothing, and the result is total alienation.
The user just sees meaningless lines, and the interface becomes impenetrable.
Exactly. So it's a massive tightrope walk. Give the brain too much information, and you trigger cognitive overload. Give it too little, assuming it will fill in the gaps. And if the mental models don't match, the user is lost.
So knowing this tightrope walk, we can look at how the world's largest tech companies are deploying these exact psychological mechanics. They aren't just using Gestalt to make things look aesthetically pleasing.
No, not at all.
They are weaponizing these laws to eliminate friction entirely.
A prime example of weaponized Gestalt is Netflix. They have absolutely mastered the principle of continuity.
Oh, I use Netflix every day. Let's break this down.
Okay. When you browse the Netflix interface, you are presented with horizontally scrolling carousels of movie and television show posters. But I want you to pay attention to the far right edge of your screen next time you use it.
Okay.
The final poster in that row is almost never shown in its entirety. It is deliberately cut off, bleeding off the edge of your screen.
Wait, I have looked at that interface 1,000 times and never considered why the last tile is always sliced in half.
It is a meticulously calculated design choice. By presenting a partially obscured image, they are creating an incomplete visual line. This triggers your brain's deep-seated drive for continuity and closure.
Because it's an unfinished puzzle.
Yes. The incomplete image implies that a continuous path of content extends just beyond the physical edge of your device. It acts as an incredibly powerful subconscious psychological magnet, pulling your thumb sideways to complete the visual sequence.
So they don't even have to ask you to scroll.
Netflix doesn't need to put a big, ugly button on the screen that says, "Tap here to view more titles." The structural layout itself generates a mild cognitive tension that can only be resolved by swiping.
That is wildly subtle and incredibly effective.
It's brilliant.
The research also points to massive productivity tools, right?
Yeah.
Like Figma and Notion, which lean extraordinarily hard on the principle of similarity.
Figma is a great case study for this.
These are complex platforms with hundreds of tools, menus, and options. When you analyze their toolbars, you realize every single icon shares the exact same stroke weight, meaning the literal thickness of the lines drawing the icon and the exact same corner radii on their bounding boxes.
Down to the pixel.
Down to the pixel. Because the visual styling is so fiercely mathematically consistent across the entire platform, the brain immediately applies the similarity rule. It decides everything here belongs to the same functional family.
And that dramatically lowers the learning curve, because the user isn't wasting cognitive energy trying to decipher differing visual styles.
And if we look at Google, or the layout of a typical Gmail inbox or Amazon's homepage, we see absolute dominance over figure ground and proximity.
Let's take Gmail, for instance.
Okay.
You have a massive list of emails. And within an open email, you have options to reply, forward, archive, or delete. Often, there are very few hard borders or dividing lines between these distinct actions.
Right, it's mostly just text and icons.
Instead of lines, Gmail uses highly calibrated proximity, just the exact right amount of negative space to group the reply actions together and group the destructive actions, like delete, further away.
So you don't accidentally click the wrong one.
Exactly. And Google's main search page does this with figure ground. An ocean of white space serves as the ground, isolating a single high-contrast search bar as the figure. The brain requires zero effort to identify the actionable element.
It's completely unignorable.
Yeah.
And this extends far beyond websites and productivity apps into interactive media. Video games are a brilliant arena for Gestalt.
Oh, video games are where this gets really interesting.
Because the ultimate goal of game design is deep immersion. You want to remove the clunky traditional user interface like health bars, text menus, blinking arrows as much as possible.
You don't want a screen cluttered with text.
The game journey is a phenomenal case study mentioned in the sources. You are dropped into a vast, sprawling desert environment with zero text telling you what to do, where to go, or what items you can interact with.
None. Just sand.
Just sand. But the developers brilliantly utilize the similarity principle. Any object in the environment that responds to the player flying fabrics, ancient ribbons, specific symbols, they all share the same glowing visual cues and warm, distinct color palettes.
So once the player's brain learns that glowing ribbon equals interactive,
Yeah.
you can intuitively navigate a massive, complex game world without ever reading a single instruction.
You just follow the similarity. Another fascinating example cited in the gaming UX research is the game Inside.
That game is fantastic.
It's so dark, but so good. There's a segment where the player uses a mind control helmet to take command of a group of mindless background characters.
Right, you get a whole mob following you.
Exactly. It could be chaotic trying to track multiple characters on screen, but they use the common fate principle to perfection. When you push the joystick forward, the entire mob of characters moves in exact, flawless synchrony.
They stop when you stop. They jump the exact moment you jump.
Because their motion is perfectly unified, the player's brain stops perceiving them as 20 individual characters and immediately begins processing them as a single, massive, multi-limbed tool. The synchrony binds them into one object.
Human-computer interaction, or HCI, has a specific term for what all these companies and designers are trying to achieve with this. They are trying to reduce the gulf of execution.
The gulf of execution. Tell me about that.
The gulf of execution is the cognitive and physical gap between a user's underlying goal and the actions required by the system to achieve that goal.
So how hard it is to do what you want to do.
Simply put, yeah.
Yeah.
If you want to search for a specific product on a website, but the search icon is hidden in a hamburger menu that uses a confusing icon, the gulf of execution is wide.
It requires conscious thought, searching, and translation of the interface to achieve the goal.
Right. But when Gestalt principles are deployed flawlessly, that gulf shrinks to absolute zero. The user forms an intention, and the interface naturally affords the action without requiring translation. You just act.
You just act. But I understand the drive for seamlessness, but I find myself wondering about the implications of this hyper-optimization.
It's a double-edged sword.
It really is.
Mm-hmm.
Are we being conditioned? I mean, if every single major app on my phone uses the exact same Gestalt applications for their primary navigation, their checkout flows, and their engagement loops, are we losing our ability to consciously evaluate our digital actions?
When the friction is entirely removed, we are basically running on cognitive autopilot.
Exactly. Are we just sleepwalking through our phones?
That tension between processing fluency and user autonomy is a significant area of study right now. When an interface perfectly conforms to our Gestalt expectations, the processing fluency is incredibly high. And biologically, high processing fluency feels good.
It feels easy.
It feels safe, intuitive, and satisfying. But extreme fluency can absolutely bypass critical evaluation. A user might click agree, subscribe, or buy now, not because they have thoroughly processed the financial or privacy implications of the decision.
But simply because the visual flow heavily afforded that action, and the brain was enjoying the frictionless ride.
Exactly. You're just sliding down a well-greased chute.
Wow. So to really grasp the gravity of that, we have to move beyond just observing layouts and look at the actual biological data. What actually happens to a person's eyes, and consequently their wallet, when these visual rules are manipulated?
The research gets incredibly granular here.
It does. It gets deeply into the science of visual effort and purchase cognition. Let's talk about the MDPI eye tracking study first.
This study is so revealing. Researchers didn't just ask people what they liked. They tracked the microscopic, involuntary movements of the participants' eyes as they viewed images composed using different Gestalt rules.
And they measured two crucial metrics, right? Fixations and saccades.
Yes. Fixations are the moments the eye stops moving to absorb detail. Saccades are the rapid, involuntary, jerky movements the eye makes as it darts from one focal point to another.
To give you, the listener, some context on saccades, your eye isn't panning smoothly across a scene like a movie camera on a dolly.
Not at all.
The fovea, which is the part of the eye responsible for sharp central vision, is actually tiny. So your eye is constantly darting around, making 3 to 4 saccades every single second, taking these high-resolution snapshots that the brain then stitches together into a cohesive picture.
It is a highly active mechanical process.
So the MDPI study found that when participants viewed images utilizing strong closure and clear figure ground composition, their sightlines were highly concentrated. The viewers exhibited far fewer saccades.
Their eyes locked onto the subject easily, grabbed the necessary information, and rested.
And unsurprisingly, the participants rated these images as highly stable, simple, and aesthetically pleasing. The brain didn't have to burn energy commanding the eye muscles to dart around.
In stark contrast, the researchers analyzed how the eye responds to compositions that rely heavily on the similarity principle without the anchoring structure of figure ground or proximity.
So just a bunch of similar stuff everywhere.
Exactly. In these images, many elements shared visual traits, but there was no clear hierarchy. And the eye tracking data lit up. It showed massive, scattered eye dispersion.
The eyes were just bouncing everywhere.
Frantically, the viewer's eyes were darting all over the image, executing high numbers of saccades, constantly making micro comparisons, trying to determine what was the most important element.
Because there was no dominant figure, the brain was trapped in a loop, desperately searching for a focal point to anchor its understanding of the space.
Exactly. The brain was forcing the eye to do more physical work just to extract meaning, and the subjective feedback matched the biological data perfectly.
People hated them.
They did. These images required significantly more time and mental effort to process, and the viewers universally gave them lower aesthetic scores. They found them complex, confusing, and unpleasant.
Now, we take that biological reality of visual fatigue, and we apply it to the second major piece of research we're looking at today, the e-commerce user interface study.
This is where it hits the bottom line.
Oh, totally. In this study, researchers built entirely distinct digital prototypes to test how different interface layouts and color schemes directly impacted human cognition, mood, and most importantly, behavior.
They wanted to see if it changed how people spend money.
Right. They gathered a cohort of users and tracked them as they navigated these prototypes. One immediate finding was a massive preference regarding contrast modes. 58% of the users strongly preferred light mode interfaces, while only 26% favored dark mode in this specific e-commerce context.
The light mode preference is interesting, often relating to astigmatism and how the eye focuses on dark text on light backgrounds versus light text on dark backgrounds.
Light text on dark backgrounds can get kind of blurry for a lot of people.
It creates a halation effect, yeah. But the truly explosive data point from the e-commerce study is the behavioral impact. 66% of the participants explicitly reported that the color schemes and the structural layout directly influenced their purchase decisions.
66%. Two-thirds of the people.
The visual design was a primary driver in their willingness to hand over money. Furthermore, 46% of the participants noted that they felt significantly more confident and secure interacting with interfaces that aligned with their visual expectations and processing preferences.
When you synthesize the MDPI eye tracking data with the e-commerce behavioral data, a profound psychological mechanic is revealed. Cognitive load is inextricably linked to consumer trust.
They are tied together.
If an e-commerce website is poorly structured, like if it forces the user to navigate a chaotic layout with terrible figure ground contrast, making the text hard to read and the buttons hard to find, the user's eyes are forced to execute more saccades. This generates literal physical and cognitive fatigue.
And what is brilliant, but also deeply concerning, is that the human brain subconsciously misattributes that biological eye fatigue.
Yes, this is the craziest part.
It doesn't think, oh, my eye muscles are tired because this layout is bad. It translates that cognitive strain into an emotional response. It generates a feeling of mistrust toward the brand, the product, and the platform.
Friction in visual processing directly equals friction in trust. If your brain has to work excessively hard just to locate the add to cart button or decipher the shipping policy, it subconsciously begins to extrapolate that difficulty.
It starts wondering, is their return policy going to be equally convoluted?
Right. Or is their customer service going to be a nightmare? Or is the product itself poorly constructed? The cognitive strain just poisons the emotional well.
But let me explore a potential contradiction here, just based on what we've been talking about.
Okay, let's hear it.
In the MDPI eye tracking study, images relying heavily on similarity cause severe eye dispersion and mental fatigue.
Right.
But when we were talking about Figma and Notion earlier, we praised them for using similarity, making all their icons share the same stroke weight to dramatically lower the learning curve.
Oh, I see where you're going.
So, is similarity a tool that builds trust and understanding, or is it a mechanism that causes chaotic eye dispersion and frustration? How can it be both?
Okay, that's a great catch.
Okay.
The expert clarification on this is that it is entirely dependent on how the principles are layered. Similarity is incredibly powerful for defining functional relationships, like grouping icons into families, or training the user that blue text is clickable.
Right, it's good for grammar.
Yes. The danger, which the MDPI study highlighted, arises when a designer relies solely on similarity while completely neglecting proximity and figure ground.
Ah, okay.
If every single element on a dense dashboard looks visually similar and they are all spaced equally, you strip away all hierarchy. You create a phenomenon known in design circles as a sea of sameness.
A sea of sameness, that sounds awful.
It is. So the eye is just wandering over a perfectly uniform grid, unable to find an anchor because nothing stands out as the primary figure.
Yes. You must use the grouping power of proximity to build structural blocks, and the contrast of figure ground to highlight the actionable elements, to actually guide the eye through that sea of similar elements.
This trap of creating a sea of sameness is just one way designers can accidentally sabotage a product. The research outlines several critical, common mistakes designers make when they violate these deeply ingrained Gestalt expectations, and the massive impact this has on accessibility.
Yeah, violating Gestalt expectations doesn't just make a site look ugly, it physically breaks the interface.
Let's talk about some common mistakes.
One pervasive mistake is an over-reliance on perfect symmetry.
Symmetry's bad.
Well, the law of pregnance tells us the brain seeks order and symmetry to minimize energy. However, if a complex digital layout is perfectly symmetrical in every direction, it actually becomes visually monotonous.
It's too orderly.
The brain scans it, registers the total uniformity, and immediately glazes over because there is no visual tension. The brain needs an asymmetrical focal point, a disruption in the pattern, to command its attention and indicate where to actually begin interacting.
Okay, so symmetry makes it boring, but failing at figure ground is another massive issue, and this bleeds directly into basic accessibility.
Oh, absolutely.
When a designer decides to use low-contrast text, like, say, a thin, light gray font on a stark white background, they're actively failing to separate the figure from the ground. The visual cortex literally struggles to detect the edges of the letters.
The contrast is too low.
The result isn't just an aesthetic annoyance. It renders the text entirely inaccessible for millions of users, causing immediate frustration and basically guaranteeing they will bounce off the page.
Breaking continuity is equally destructive. Consider a multi-step checkout flow for buying a product. You usually have a progress bar across the top of the screen, right?
Yeah, showing what step you're on.
Right. As the user clicks from shipping to billing to review, if the design of that progress bar is inconsistent, like if it jumps a few pixels to the left or the spacing between the steps changes slightly from screen to screen, it severs the continuous visual line.
And the user notices that.
The user might not consciously realize the pixel shift, but their visual cortex detects the break in continuity. Subconsciously, they feel the system is unstable or broken.
Which is the exact last thing you want someone to feel right before they enter their credit card information.
Exactly. You want total stability there.
The integration with accessibility standards, specifically the Web Content Accessibility Guidelines, or WCAG, is heavily emphasized in all this research. Applying Gestalt isn't viewed as a mere best practice. It is a strict requirement for inclusive design.
It's mandatory.
Like dyslexia, for example. Supporting users with dyslexia relies heavily on a masterful application of proximity. Designers must implement generous, highly calculated spacing between lines of text, which is known as leading, as well as tracking between the letters.
Because if the proximity between lines is too tight, the visual elements crowd each other.
Exactly. The words group into an unreadable, vibrating block.
The intersection with color blindness provides another snark example. If a designer relies entirely on the similarity of color to convey critical meaning, for example, simply turning the border of a text input box red to indicate that the user has entered an invalid email address, that is a catastrophic failure.
Because a user with red-green color blindness will not perceive that similarity grouping.
Right. The Gestalt framework dictates that you cannot rely on a single dimension. You must introduce a secondary cue, you have to change the proximity, alter the shape, or introduce a distinct warning icon. The relationship and the error state must be universally perceivable regardless of someone's color vision.
So to prevent these failures, the research provides incredibly practical, actionable steps for design teams to integrate these theories into their rigorous daily workflows.
Yeah, these are great takeaways.
The most universally recommended and impactful step is to execute the initial design phases entirely in grayscale.
I love this one. It is a foundational technique that strips away the most seductive crutch a designer has. By removing color entirely from the process, designers cannot use it to artificially group elements or create hierarchy.
They are forced to rely on the bedrock principles of Gestalt.
They have to ensure that proximity and figure ground are doing the heavy lifting to organize the layout. If the structural hierarchy makes complete sense and the visual flow is intuitive in black, white, and gray, then adding color later in the process will only amplify and clarify that structure.
The analogy that comes to mind is architecture. You can't fix a structurally unsound building by painting the walls a beautiful color.
The building will still fall down.
Right. If the foundation is cracked, if the hallways lead to nowhere, the building fails. Gestalt principles are the concrete and the steel. Color is just the paint.
Another profoundly simple but effective actionable step the research suggests is the most basic form of user testing.
And it doesn't have to be complicated.
Not at all. You just put a prototype in front of a user and ask one question. What belongs together on this screen?
That's it.
That's it. If the user points to two elements that aren't supposed to be related, your proximity is failing. You don't need to rewrite complex backend code or redesign the entire aesthetic. You simply need to adjust the pixel spacing until the visual cortex groups the elements correctly.
Because in a digital landscape where users make sweeping judgments about credibility and functionality in 50 milliseconds, a violation of Gestalt expectations isn't just a minor hiccup.
No, it's a micro moment of biological friction.
And that friction compounds instantly, resulting in abandoned shopping carts, deleted applications, and a complete loss of trust.
Well, we have journeyed through a massive amount of cognitive territory today.
We really have. We started with early 20th century psychology and the phi phenomenon. We unpacked the biological imperative of the visual cortex to save energy and explored how the biggest technology platforms in the world map their interfaces directly onto our neurological hardwiring to reduce the gulf of execution.
To really cement this, we need a way to move this from abstract theory to tangible reality in your own life.
So here's a challenge for you, the listener. As soon as you finish this deep dive, I want you to pull out your smartphone and open the app you use the most.
Whatever it is.
Maybe it's a social feed, a calendar, or a banking app. Hold the phone at arm's length. Now slightly blur your vision. Squint your eyes just enough so that it becomes physically impossible to read any of the typography on the screen.
The content is totally gone.
Now look at what is left. Look at the blobs of gray, the negative space, the colored shapes. Try to identify the invisible architecture. Which Gestalt principle is actively guiding your thumb?
Is it the proximity of the shapes, creating clear groupings?
Is it the tension of closure, making you want to swipe a partially obscured image off the screen?
Or is it continuity pulling your eye down a central spine?
When you mute the content, the structural psychology becomes incredibly loud.
And as you look at that screen, it is worth considering the future trajectory outlined in the research. Everything we have discussed revolves around static or pre-programmed dynamic design. But the absolute bleeding edge of human-computer interaction involves something researchers are calling dynamic gestalt.
Okay, this concept is where the psychology moves from passive to actively responsive.
Exactly. Researchers are developing systems that integrate real-time eye tracking and biometric sensors directly into consumer devices.
So your phone is watching you back.
Oh, constantly.
Yeah.
These interfaces won't just sit there. They will actively monitor your biological state. They will track the frequency of your saccades, your blink rate, and pupil dilation to measure cognitive fatigue in real time.
So it knows when you're tired.
Right. If the system detects that your eyes are darting erratically or that you are struggling to process the layout, the interface will automatically adjust its own Gestalt principles on the fly.
It changes itself.
Yes. It might autonomously increase the negative space between elements, amplifying proximity. It might dynamically heighten the contrast of buttons, strengthening figure ground. The interface will literally reshape itself to simplify the layout and reduce your cognitive load the exact moment you become tired.
Which leaves us with a massive, almost philosophical question to ponder. As these biometric integrations become standard, what happens when our digital environments become living, breathing, responsive entities?
It's wild to think about.
If a screen is constantly morphing, expanding, and heightening contrast based on our real-time neurological exhaustion, will we ever actually see a true objective interface again? Or will we spend our lives interacting with a custom-rendered fluid psychological blanket, explicitly designed and continuously adjusted by an algorithm to keep us infinitely, effortlessly engaged without ever triggering a single moment of cognitive friction?
It is the ultimate evolution of the gulf of execution dropping to zero. It is a brilliant and simultaneously daunting frontier of technology.
It is the ultimate magic trick of the mind and the machine. Thank you for taking this deep dive into the psychological matrix with us today. Keep your eyes open, run the squint test on the digital world around you, and pay attention to where your thumb goes. Because once you see the invisible architecture, you can never unsee it.